Okay, today we're going to look at atomic mass. So we've seen on the periodic table the atomic number, and then on the bottom of those boxes you have the atomic mass. Now that atomic mass is actually an average, and more specifically it's what is called a weighted average. And it's a weighted average of all the isotopes based on percent abundance. So percent abundance is how often that particular isotope occurs in nature. Alright, so an isotope are atoms of the same element that have different mass numbers. So they have a different mass. And so if it's the same element, that means the protons are the same, but the thing that is different are the neutrons. Okay, the neutrons are what makes that different. Alright, so what is a weighted average? So if you think about our grades in chemistry class, right, we have homework, which is 5%. We have classwork, which is 5%. And we have quizzes, and those are 10%. And we have labs, and those are 30%. And then we have tests, and those are 50%. So let's just, to make things easier, we're just going to have one grade in each category, although we know that would be not true. But let's say we have 100 for our classwork and our homework. We got a 90 for our quiz. And our lab, let's say, is 85. And on our test, we got a 93. So what would be our average? Well, one thing we should be able to tell is based on the fact that this is a higher weight, that the average will be closer to 93 than it would to anything else, because this has more weight, right? So your tests count more, in other words. Likewise, when we talk about a weighted average of the isotopes, the percent abundance, which is greatest, will have a greater contribution to the average mass. Just like the test being 50% has a greater contribution to your overall average. So how would we find our average then in chemistry? Well, we would take our 5%, change it to a decimal, and multiply by the grade for our homework, right? So that would give us 5. We do the same thing for the classwork. That would also give us 5. And then we would do the same for our quiz, be 0.1 times 90, right? And that would be 9. And then we would have 0.3 times our 85. That one I have to use my calculator for. 0.3 times 85 gives us 25.5. And then 0.5 times 93 for our test gives us 46.5. Now, to get our average, we would simply add all those together. And we would get a 91. So our average would be 91%. And you see that that average is closer to the 93 than to the 85, right? Alright, so what is the atomic mass of an element which has two isotopes? Isotope 1 has a mass of 6.941 AMU and a percent abundance of 92.5. Isotope 2 has a mass of 6.041, and what would be the percent abundance for the second isotope? Well, all of these percentages added up to equal what? Right, 100. Likewise, these percent abundances have to equal 100 as well. So if the percent abundance has to add to 100, well, if one of them is 92.5, well, what's the other one? So we just subtract from 100, right? And we get 7.5. And that would be a percent. right? So let's calculate the atomic mass then. So the first isotope has a mass of 6.941 times the percent abundance, which would be 0.925. The second isotope has a mass of 6.041 times the percent abundance, which would be 0.075. And so we multiply those together, and we get 6.420. Again, when we are rounding based on our significant figures, what was measured, the mass was measured. The percent abundance wasn't measured. We would calculate the number of atoms. We would add the number of atoms.
Miss Lowry, please see Miss Berry. Miss Lowry, please see Miss Berry.
And so therefore that would not be a...
Your verification sheets were due to Miss Berry at 9 a.m. Your verification sheets were due to Miss Berry at 9 a.m.
And therefore, you would round to your number of significant figures in your measured mass. So our measured mass in the second one, 6.041 times 0.075, gives us 0.4531. Again, I needed 4 significant figures because I had 1, 2, 3, 4 in my measured mass. And so then finally we would add those together. And we get 6.873 AMU. Because remember, when we add, we go by the least number of places after the decimal, and that was 3 places here. Now, the last question, what is the element? Well, we can look on the periodic table and find what element has a mass closest to that, and we should find that that is lithium. Alright, so for class tomorrow, I want you to try the next 2 problems, and we'll go over those tomorrow at the beginning of class.